Hey everyone. Okay, so today is our last lesson of the polynomial unit. We're going to take a look at just some special cases of factoring that we haven't quite dealt with yet. Now, before we get going too deep into that, just a quick review. Remember, I want factoring to be one of the things you are like super comfortable with. So I'm just going to review the basics one more time. We're going to factor this through decomposition. You are looking for two numbers that multiply together to give you 14 times 3. 14 times 3 is 42. So negative 42 and add together to give you negative 19. So you're going to start going through the factors of negative 42. We've got 1 times 42. If my negative is on the 42, that would add together to give me negative 41. That doesn't work. I get 2 times negative 21. If I add those together, that gives me the negative 19 that I'm looking for. Okay, so I know my two numbers are 2 and negative 21. I'm going to break that middle term down into the negative 21c and the 2c. Now I'm going to factor the front 2 and factor the back 2. Out of the front 2, I can take out a 7c, and that would leave me with 2c minus 3. And then here, I want you to notice that I have 2c minus 3, but I have to factor something out. I have to finish the process, okay? And so essentially what I'm doing is factoring over 1. So that's going to be a 1 times 2c minus 3. Now I can see that the 2c minus 3's are the same. And so that's a common factor that I can pull to the front and be left with 7c plus 1 times 2c minus 3, okay? All right, try this guy. Looking for two numbers that, well, actually, first of all, 96 and 50 and 6. Remember, the first step to any factoring is to take out a greatest common factor. So when I look at all of those, I for sure can just take out that 2. Everything is even. So if I take out the 2, I'd be left with 48r squared minus 25r plus 3. Now, 48 times 3 is 144. So I'm looking for two numbers that multiply together to give you 144 and add together to give you that negative 25. That tells me both numbers have to be negative, because a negative times a negative will give me a positive. Okay, so you should pause me and see if you can find those yourself. Remember, the 2 here in the front will now stay along for the ride. The two numbers are negative 16 and negative 9. Negative 16 plus negative 9 gives me that negative 25. And negative 16 times negative 9 gives me the 144, okay? Now, I'll factor the front 2, factor the back 2. Out of the front 2, I can take out a 16r, and that would leave me with 4r minus 1. And out of the back, 3r minus 1. And then out of the back 2, I can take out the negative 3, and that would leave me with 3r minus 1 as well. So 16r minus 3 becomes one of my binomials times the 3r minus 1 that I pulled out as the greatest common factor. So final answer, 2 times 16r minus 3 times 3r minus 1. Okay, all right. So in this lesson, we'll look for patterns in expanding and factoring special trinomials. So the first one we're going to look at is something called perfect square trinomials. Now, I mentioned this in a previous lesson, but we want to just unpack what the pattern might look like here. So I've got x plus 1 all squared. Now, what that means is x plus 1 times x plus 1. So you can write x plus 1 times x plus 1 and then multiply it all out together. So that's x times x plus 1 times x plus 1, okay? You should end up, when you do that, with x squared plus 2x plus 1. Okay, I want you to pause me and do the other two by yourself. Okay, and so you should have ended up with x squared minus 2x plus 1, and you should have ended up with 4x squared plus 4x plus 1. Now, what are the patterns I want you to see here? I want you to see that the first term gets squared. Okay, I want you to see that the last term gets squared. And then I want you to see that the middle term is actually double the product of these guys, okay? X times 1 is x, and then double that would give me 2x, okay? I'm going to scoot over to the last example just to show you that again, because there's not there's just different numbers there to look at, whereas the x squared was the same here. So I start with 2x, I get squared, and that would be 4x squared. Okay, then I take a look at the 1 again. The 1 squared gives me the 1, and then I take a look at the product that should get doubled. So 2x times 1 is 2x, and then 2x doubled gives me that 4x there. Okay, so if I want to see if I have a perfect square trinomial, I'd be looking for a format that looks something like this. I can see a perfect square as my front term. I can see a perfect square as my back term, and then 2 times the square root of each of those would be the middle term. Okay, and that works for addition or subtraction. Okay, so a minus bl squared gives me a squared minus 2ab plus b squared. All right, so if I try and find that pattern here, okay, if this was a perfect square trinomial, I would have a perfect square in the front, which I do, and a, so that first term, let a would be x, right? I would have a perfect square in the back, which I do, and so the b value there would be 3. And then the middle term should be 2ab. Well, is the middle term 2 times this? Yes, it is. Okay, so that is a perfect square trinomial, and it's going to end up being x plus 3 all squared. Okay, let's take a look at this guy. I do have a square root in the front, so my a value there would be 2x. I do have a square root in the back, so my b value would be 5. This is supposed to be 2ab. Well, if a is 2x and b is 5, 2ab would be 10x. That is not what this middle term is, so that is not a perfect square trinomial. Oops, sorry, I gotta change that to my mouse. Okay, and then the last guy here, my a value, this is a perfect square. My a value would be 4. This is a perfect square. My b value would be 7x. The middle term has to be 2ab. Well, a times b here is 28x. 28 doubled is 56, so that does work, okay? Remember, it doesn't matter whether that middle term is positive or negative. It just means whatever sign that will be here, that will actually be the sign in the middle of the binomial. So I end up with 4 minus 7x all squared, okay? All right, so that's the first guy we have to deal with. The second guy we have to deal with is what's called a difference of squares. I would like you to pause me and multiply these 3 sets of binomial pairs out. Okay, and something very special happened with both of these, all 3 of these, I mean. What happens is when you multiply all these 3 out, you end up with 4 terms like you normally would for any binomial times binomial, but the 2 middle terms actually add to be a 0, and so they're not included in part of your answer. So you ended up with the first one to get x squared minus 4. With the second one, you got x squared minus 25. And with the last one, you got 16y squared minus 25. Now, remember that this whole conversation is around factoring. So we're going to take a look at this and say, do I know enough information to figure out how to get back to the multiplication sentence? Factoring is creating a multiplication sentence from an original polynomial. Now, what's special about these guys is they're not trinomials at the first glance. X squared minus 4. Well, I want to talk about that for 1 sec. You could look at them as trinomials. Now, I'm not suggesting that you do this, but I just want you to, I want to show you, remember I said a couple slides ago, decomposition will always work, right? Well, decomposition will always work if it's a friendly trinomial. This is not a trinomial, you're missing your x term, right? It should go x squared plus some sort of x minus 4. Well, it's there, it's just that it's 0. So really I could write this as x squared plus 0x plus, or sorry, minus 4. Then I'd be looking for 2 numbers that multiply together to give me negative 4 and add together to give me 0. Well, that would have to be positive 2 and negative 2. Okay, so decomposition still works. Now, I don't want you to put a 0 here. That's not what I'm going for. I just want to prove the point that decomposition will work for all friendly trinomials. What I do want you to see, though, is that x squared is a perfect square and -4 is a perfect square. So, or sorry, I shouldn't have said -4 there, just 4 is a perfect square. So what I need you to see here is that this is a perfect square, subtract a perfect square. We call that a difference. Remember, difference in math means subtraction. It's a difference of squares. Now, a difference of squares will always factor into two binomials where the front guy is the square root of the front guy. So that would be an x and that would be an x. The back guy is the square root of the back guy. So this would be a 2 and this would be a 2. And then one of them gets added and one of them gets subtracted. Okay? So let me just clear that ink for you. And algebraically, we would say a squared minus b squared will equal a minus b and a plus b. So that's the same thing I just did, okay? The front guy, the square root becomes the front guy of both of my binomials. The back guy, the square root becomes the back guy of both of my binomials. And then one gets added and one gets subtracted. Okay? I will tell you up front, I've been teaching this course for like hundreds of years. For whatever reason, when we come to factoring, differences of squares, kids don't see right off the top of their head. They don't recognize it as a difference of squares. So what I need you to do is really be very keen that when you see two terms, you want to ask yourself, do I have a difference of squares here? Okay. All right, so let's try a couple of examples together. X squared minus 16, is that a perfect square minus a perfect square? Yes, it is. The square root of x squared is x. The square root of 16 is 4, so I end up with x plus 4 and x minus 4 as my two binomials. Doesn't matter which one comes first. Remember that the order of multiplication doesn't matter. So you could have had x minus 4 times x plus 4. That's perfectly fine. Okay, the 9m squared minus 64n squared, is that a perfect square minus a perfect square? Yes, it is. The square root of 9m squared is 3m, and the square root of 64n squared is 8n. So I end up with 3m plus 8n times 3m minus 8n. Okay, I'm gonna go over here to the green guy, 25x squared minus 16. Is that a difference of squares? Yes. The square root of 25x squared is 5x. The square root of 16 is 4, so I end up with 5x plus 4 and 5x minus 4. And then the last guy on this slide, I do have a perfect square minus a perfect square, so I do have a difference of squares. The square root of x squared y squared is xy, and the square root of 49 is 7. So I would have xy plus 7 and xy minus 7. Okay. Now, factoring trinomials in two variables or with higher exponents is the next thing to talk about here. Let's see what you remember and can apply from what we already know. These trinomials look more complicated, okay? That's gonna get a little messy. But in math, like in life, we can find beauty in the mess, okay? The process of decomposition will always work as long as your trinomial is friendly. Now, that's where you would probably say, Hill, what are you talking about with a friendly trinomial? This is what I'm talking about for a trinomial to be friendly, okay? If, I just want to turn on my ink here, if the exponent on the front is represented in the middle but half of its value, then we're friendly. If the exponent on the back is represented in the middle but half of its value, we're friendly. Okay, so I've got an x4 on the front, but I got an x squared in the middle. So those guys are fine. I've got a y squared on the back. I've got a y in the middle. Those guys are fine. If that is the case, then this trinomial is friendly. And if it's friendly, decomposition is going to work for me. Okay, the only thing you have to remember is when you go to break down this middle term here, whatever two numbers you decide, whatever was beside your coefficient originally has to stay beside. So if my two friendly numbers here are 2 and 3, then it would be 2x squared y plus 3x squared y, okay? All right, so remember, always factor until you can factor no more, okay? So you are constantly going to do the process of factoring, look at your answer, and then say, hey, am I done, or can any of these be taken any further? The questions will always read completely factor, so that means you have to keep factoring. You have to do as much as possible until you can't do anything else. All right, so first guy we're going to look at is 2x to the 6 plus 13x cubed plus 6. This is a friendly trinomial because I've got an x6 on the first term, and then in the middle I have half of that exponent represented with an x cubed. There is no greatest common factor, so I'm going to go right to decomposition. I am looking for two numbers that multiply together to give me 12 and add together to give me 13. Those two numbers are 1 and 12. So I'm going to break my 13x cubed into 1x cubed plus 12x cubed, and then I can factor the front and factor the back. Okay, so looking at the front two, looking at the back two, in the front two, I can take out a 2x cubed. That would leave me with x cubed plus 6. Now, that's exactly what I want in the back, but I have to take something out. I have to finish the process that I've started, which was factoring the front two and factoring the back two. So I take out a 1 from the back two, and then that way I get my greatest common factor. X cubed plus 6 is a greatest common factor. It can get pulled out, and I would be left with 2x cubed plus 1. Okay? See, so there's nothing weird, there's nothing nefarious going on. This is exactly like it was 2 lessons ago when I taught you decomposition. It just looks a little messier at the beginning, but the process is exactly the same. Okay, x to the 4 plus 14x squared plus 24. This is a friendly trinomial because the exponent on the front is shown in the middle, but it's half of its value. This is also a shortcuttable one if you wanted to do a shortcut, because the coefficient on the front is a 1. Now, the only thing I would caution you on in your shortcut is you would have to realize that in order to get that x to the 4, your two front terms have to be x squared now, not x, right? It'll be an x squared times an x squared that will give me the x to the 4. My two numbers that multiply together to give me 24 and add together to give me 14. That's 12 and 2. So I end up with x squared plus 12 times x squared plus 2. Now, if it stresses you out that I went right to the answer, do the decomposition, okay? Decomposition will never lead you astray. Okay, x squared plus 12xy plus 32y squared. So now I've added a square on the back term, but that's okay because I see the exponent is halved in the middle term. I've got an x squared on the right side, but I've got a y squared on the right side and a y in the middle. I've got an x squared on the left side and an x in the middle, okay? So I'm looking for two numbers that multiply together to give me 32 and add together to give me 12. Those two numbers are 8 and 4, so I split my 12xy into 8xy plus 4xy. Now I'm ready to factor the front two and factor the back two. Out of the front two, I can take out an x, and that would leave me with x plus 8y. Out of the back two, I can take out a 4y, and that would leave me with x plus 8y. So x plus 8y is my common factor the way I've set this up. That guy gets pulled out and gets multiplied by x plus 4y. And so my final answer is x plus 4y times x plus 8y, or x plus 8y times x plus 4y. Okay, the order doesn't matter of your factors. Okay, good. 3a squared minus 23ab minus 8b squared. This is a friendly trinomial. The exponents on the outside are halved on the inside. So I'm ready to do decomposition, looking for two numbers that multiply together to give me negative 24 and add together to give me negative 23. That would be negative 24 and positive 1 as my two numbers to decompose with. So I go ahead and I decompose. I'm going to factor the front two, factor the back two. Out of the front two, I can take out a 3a, and I'd be left with a minus 8b. Out of the back two, I can take out a b, and I'd be left with a minus 8b. So a minus 8b is my common factor. That guy can get pulled to the front, and I'd be left with a minus 8b times 3a plus b. Okay? All right, good job. 3a squared minus 31ab plus 10b squared. Okay, same thing. It is a friendly trinomial. I'm looking for two numbers that multiply together to give me 30, the 3 times 10, and add together to give me negative 31. That would be negative 30 and negative 1. So I break my middle term down into the negative 30ab and the negative 1ab. Remember, whatever letters go with the number, they have to appear on both of your decomposed numbers, okay? Now factor the front two, factor the back two. Out of the front two, I can take out a 3a, and I'd be left with a minus 10b. And then over here, I'm going to take out a negative b. Remember, my front guy is negative, so whenever your front guy is negative, you take the negative out. Take out a negative b, and I'd be left with a minus 10b. So the a minus 10b is my greatest common factor. Pull that out and multiply it by the 3a minus b that would be left over. All right, 72y squared minus 50. As in all things, the very first question you always ask yourself, is there a greatest common factor? Okay, there is a 2 here that's common, so I'm going to factor the 2 out, and that would leave me with 36y squared minus 25. Now, I'm left with 2 terms in here. What do I need to ask myself if I'm staring at 2 terms? Do I have a difference of squares? 36y squared is a perfect square. 25 is a perfect square, so I have a perfect square minus a perfect square. That is a difference of squares. The square root of 36y squared will give me 6y. The square root of 25 will give me 5. So I end up with 6y plus 5 and 6y minus 5. And don't forget that that 2 has to stay in the front, along for the ride the whole way through. Okay? All right, 12a cubed minus 75ab squared. I can take out, what can I take out? I can take out a 3 and I can take out an a. So 3a is going to be my greatest common factor. When I take that out, I'm left with 4a squared minus 25b squared. 4a squared is a perfect square. 25b squared is a perfect square. So I have a difference of squares. The square root of 4a squared is 2a. The square root of 25b squared is 5b. So I'll end up with the 3a at the beginning, and then 2a plus 5b and 2a minus 5b. Remember, I said always factor until you can't factor anymore. When I look at these 3 factors now, there's nothing else I can do. I can't do anything with a 3a. I can't do anything with a 2a plus 5b. I can't do anything with a 2a minus 5b. That tells me I'm done. I have factored until I could factor no more. Okay? All right, 16x to the 4 minus 1. Now, this example is special to my heart for a couple of reasons. Number one, lots of kids say, oh, there's nothing I can do here, because we don't think about 1 as a perfect square. The square root of 1 is 1. So 1 is a perfect square. Be very careful with that, okay? So the square root of 6, so this is a difference of squares. The square root of 16x to the 4 is 4x squared, and the square root of 1 is 1. So I end up with 4x squared plus 4x squared plus 1 times 4x squared minus 1. Okay, now, like every other question, I look at my answer and I say, is there anything else I can do? 4x squared plus 1. There is nothing else I can do with that, because that is an addition of squares. It is not a difference of squares, okay? But this guy is another difference of squares. 4x squared minus 1 is a difference of squares. The square root of 4x squared would be 2x. and the square root of 1 would be 1. So that guy can break down into 2x plus 1, 2x minus 1. Don't forget that the 4x squared plus 1 stays along for the ride. He needs to be in every line after. Okay, so this would be my final answer, 4x squared plus 1 times 2x plus 1 times 2x minus 1. All right, 5x to the 4 minus 80y to the 4. So again, first step would be to look for greatest common factor. In this case, that would be 5. I take the 5 out, and I'm left with x to the 4 minus 16y to the 4. I see a difference of squares there. The square root of x to the 4 is x squared. The square root of 16y to the 4 is 4y squared. So I end up with 5 times x squared plus 4y squared times x squared minus 4y squared. Now, there's nothing I can do with the 5. He's done and just along for the ride. There's nothing I can do with the x squared plus 4y squared, because that, although those are perfect squares, that is an addition of squares, not a difference of squares. So there's nothing else I can do there. But that last fella is another difference of squares, x squared minus 4y squared. So the square root of x squared is x, and the square root of 4y squared is 2y. So I end up, this guy breaks down into x plus 2y and x minus 2y. And now that concludes this particular question. There's nothing else I can do there. I can't take that any farther than what I've done. Okay. All right. Awesome. So those are some of the special cases that you're going to see. Your homework is there. Do lots of practice, okay? And make sure you're coming and checking with me with any questions that you have, okay? I hope this has been helpful. You will also see some review now that we're done the end of the unit as you start preparing for your test, okay? And so now I will catch you again at the beginning of Unit 2 on exponents and radicals, okay? Have fun studying. Take care.